Okay, so let's talk about graphics a little bit. The old view way of doing things was a real pain because you'd have to create a subclass of a view type, override some on draw methods, do all your functionality in there, and then pass around a whole bunch of parameters using XML. Whereas with Compose, hey, you have a function that takes parameters, it's nice and easy, and we can just directly say draw stuff. So it makes things a lot simpler. The way we're going to do it is you're going to use a Canvas composable, and he gives you a bunch of functions that you can use to draw lines, rectangles, ovals, all sorts of different things like that. He also gives you some functions to apply rotation, scaling, translation, clipping, and different types of transforms. One of the things to note here is, like most graphic systems in computers, 0, 0 is the upper left corner of the screen. So Y goes down, X goes from left to right. That is in direct opposition of math, where with math you have your 0, 0 in the lower left corner. The first quadrant, when you're dealing with math, 0, 0 is the lower left, but in a computer, this is really a historical thing from when we used to use cathode ray tubes, where the beam would scan starting at the top, going left to right, then move down, left to right, then move down, left to right. And early graphic systems were completely tied to exactly what the CRT was doing. So, in order to draw things, we would actually draw them in the order that the CRT was drawing things. Uh, we've just historically stuck with that. I think there are probably some other systems. I think I'm trying to remember the graphic system I saw where it did the transform for you. So it had 0, 0 at lower left, but just keep in mind 0, 0 is upper left. Okay, so when you're using this, you'll call Canvas, and then inside there it passes in something called a draw scope as the receiver to your Lambda. So this Lambda right here takes in a receiver called a draw scope, which has a whole bunch of functions. Draw rect is one of them, for example. Um, each of those you can use to draw stuff on the screen. Now, there are some data structures here that are a little bit on the interesting side. Offset and size, for example, here. These two are what are called value classes in Kotlin. And what a value class is basically just kind of a class definition for a single primitive value. So it could have a single primitive value like an integer or a float, long, Boolean, whatever. And Kotlin will treat these as though they're objects, but they really aren't objects. And what's a big advantage to these is that they won't need to be allocated and they won't need to be garbage collected. Now, for example, what the offset is doing is it takes the two values, the x and y, and combines them into a long, or actually no, a double, because they have two floats there. So it will actually take those and combine them into a double, so you have a single value. And then when you're referencing, it can just pull those values out of there. This makes it so it feels like you're doing these things object-oriented, but you're really not. It's just using a value class behind the scenes. Now, there are a couple places where you have to be careful on this. You can't assume that everything like this in the graphics API is a value object, so you may want to check. There's one in particular that I'll point out a little bit later that we want to always do a remember on, as opposed to just calling these wherever we need to. Keep in mind that your composable could be called for every single frame being displayed on the screen. So this is like lots of times per second. So you really don't want to be allocating objects and then letting them get garbage collected at some point. If you have an object that you allocate and you're just reusing the same one over and over, that's perfectly fine. But if you're just creating an object temporarily, and then inside of your composable, every single time it's composed, you're recreating that object, you're bound to have some jitter in your application where it's going to kind of stutter a little bit, or jank is what they usually call it. So be careful when you're using things that look like they're creating objects. Offset and size, though, those are perfectly fine, and I'll show you what those look like in a little bit. Now, what you do to create a custom component is just create a composable function like we've been doing before. So we're going to create some kind of custom view. We have some parameters for how to modify it, and then a canvas that just draws things. Boom. Nice and simple. So that's what we're going to be doing, is a lot of this type of thing, where we're going to create some custom components and then do things with them. What we're going to start with here is a gauge component. And this is going to be a very simple component. It's going to take up a rectangle on the screen, and it's going to grow from the bottom up. So we're going to have an outline that shows us what the bounds of the gauge are, and then we're going to fill it in starting at the bottom and get it higher and higher as the value raises. And we'll see how that actually ends up working. Okay, so we're going to start off in here. Let's go into there, and I'm going to create a new file. And this is going to be gauge. Wow. There we go. We'll spell that right this time. And then inside here, we'll say we have a composable fun gauge. And he's going to have some parameters on him. So we'll have an outline color, which is going to be a color. Make sure you get the one that is Compose UE graphics, not Android graphics. And then we'll do a fill color. And let's do an outline width. And am I looking at the right one here? Ooh, get out of there. Yeah, I wanted to use DP for that. And I'm going to let this be passed in as a DP so that we don't have to do the conversion. This component can do the conversion for us. We'll give it a value, which is going to be a float. And this is going to be from 0 to 1, well, 0.0 to 1.0 f. And that'll just represent a proportion of the overall space. And then we'll have a modifier. And we'll just open it up like that. So those are parameters coming into this gauge. And then we're just going to have a canvas here. And the canvas is going to take that modifier. And let's give it a little padding in there as well. So I'm going to say modifier.padding and maybe 8.dp. Okay, so now inside of this, we've got to try to figure out how we want to draw that outline, how we want to do the fill. So the first thing we're going to do is draw our outline to show where this thing actually exists. So let me put a draw rect in here. And this function, if we take a look at him, is defined by draw scope. And we're going to have some object that is a draw scope passed in to the function that is the body of this canvas call. So we're going to call draw rect, and he's going to have inside of him a top left, which is going to be an offset. And we will say inside there, the top left corner of this is going to be 0f, 0f. Now there just happens to be, because this is a really common offset, offset defines a 0. Oh, where is he defined? Yeah, here we go. He defines an offset called 0, which just passes that in. Now notice here, it's passing in a 0 long. It's just a packed value. When we create an offset, using this offset function up here, which looks like a constructor, he's actually taking those two floats and packing them together, and it looks like he's storing them as a long. And so then he can pull those apart. He can use them however he wants. Offset.0 is just directly passing in a 0 for that value. And then there's also an offset.infinite, which is just trying to say this is a really, really big offset. And let's go back in here. So instead of saying offset with 0, 0, I'm going to just say offset.0, and we're going to reuse that same instance each time. Now we also need to say what size this rectangle is, and he's going to be a size. And once again, this guy is a value class, so he's not really an object being created. And so the size of this guy is going to be as big as our screen is here. So I can say size, which is provided by DrawScope, dot width and size dot height. Let's take a look at what size is here. If I look at size, size is a size. And what's it expecting here? A size. So instead of actually creating a brand new size, I could just go ahead and directly pass in the size that was passed to me. Now I also need to say what kind of style we use for this. Are we filling it in, or are we giving it an outline? So I'm going to say style equals stroke, passing in join equals, actually I didn't import him yet. Hello. That's the one. There we go. So the join, which is how any lines that where the edges are, the corners, is going to be either curved, mitered, or possibly just squared off. So I'm going to say stroke join dot round. In this case, I'm just going to have rounded corners, and then I'm going to give it a width for the outline, which is going to be the outline width coming in. But the outline width coming in is in DPs. Here I need it in pixels. So what I need to do is convert from DPs to pixels. To do that, I have to know what density my screen is, and then I can multiply by that density to convert it from DP to pixels. To do that, we need to get a hold of whatever the current density of the screen is. So I can say width local density dot current, and that will give me a density context. Now, it is called a composition local, which is a value that can be set to nest other values. So if somebody outside of me, the system itself, has set local density, and I can use it in any of my calls at any level. We've seen some things like this, like when I said material theme dot typography. Material theme is a composition local. He holds on to the value of the current theme, and I can access him at any level of call that I make inside of my composable functions. I don't recommend you define your own ones. It's super tempting if you have a bunch of parameters that need to go down several levels, but it ends up kind of feeling less pure in the function because I'm really just reaching for something that wasn't passed to me. We really should be having these functions only depend on things that are passed. So I'm really not a fan that they created these composition locals. I think they should have had a general parameter for every function called context, kind of like what they used to do in the old Android system. And that context, you could then from there ask for the current local density. That said, we're stuck with it. Just don't define your own composition locals if you can avoid them. So what this will do is this width function says take this object and make it a this being passed into the function, the lambda body that is a part of that width call. So this is going to give me access to the 2px function, which actually takes DP as a receiver. So inside here, I'm just going to move this stuff up, and I'm going to say val outline width px. And actually, let me, just to make this a little bit more clear what's going on, let me rename him to outline width dp. So outline width px equals outline width dp dot 2px. There we go. And so I can change this now to px, and he should be happy. And what is he unhappy about that? He shouldn't need all of those. I think I imported the wrong drawrect. No. Okay, so drawrect top left, size, and style. That's really all I should need. So that's the one that I should be calling. Why do I think we've got another one of those issues? Well, let's see what happens. So I'm calling drawRect. I'm just double checking my source code that I had. Oh, I didn't pass in the color. That's why. So color equals outline color. There we are. Now I'm good. So this will draw our outline on the screen. And right now I'm not using the fill color of the value. Let's go back to the main activity and see how we can actually call this. So we have our scaffold. I'm going to get rid of our greeting. And inside of here, I will call gauge. And I'll say outline color is color.blue. And fill color is, let's say, green. And outline width dp is 3.dp. And value is, let's say, 0.6f. And then modifier equals modifier.padding, inner padding, and we'll say within there we will fill whatever max size is left. Okay, let's try this and see what it looks like when we run it. Now I'm running this on my phone. Hopefully we won't get any lockups. Okay. So I created a new project, but I didn't tweak back these couple values. Unfortunately, one of the things that they do when you create a new project is they actually go out online and take a look at what the latest versions of these guys and automatically grab them, regardless of what version you're compiling against, which isn't great. But don't blame me, I didn't write that code. So I'm going to change this back to 18 and change this back to 10, and that should do it. I did do a lot of work there on trying to reduce the number of new project templates there were, and I was working on that for quite a while, and apparently they actually implemented that after I left. I was so happy. Okay, so we got that. Let's try running it again. And there we go. So we have, here's our gauge. It's filling all that area with a little 8 dp gap around it. And that's our outline. So far, so good. Now what I'm going to do is I'm going to make that outline a little thicker, just so a problem's going to be a little bit more apparent. So what, I need to pass it in here. So outline width, let's make it 48 dp. So we'll make it really big. And just rerun this for the moment. There we go. That is a really ugly, thick border. But it'll make a little issue apparent in a minute here. So now we need to deal with the filling. And in order to fill, we need to figure out how much we need to fill. And so we're going to need to do a couple little computations. Nothing really brutal or anything here. But we're going to start off by saying val fill height is going to be size.height times value. So that's going to be the amount that we're going to fill up, but we want to do it from the bottom. So we need to figure out where our y should be, where our top left y should be. So I'm going to say val offset y equals size dot height minus fill height. So we'll just back off. And that's going to tell us where to actually start. And so now what I can do is take this drawRect, and I'm just going to copy him. And let's actually say here we're going to draw the border, and then this one is going to fill in the value. So the first thing we're going to do is change style to fill. which is just an object. And our size is going to be size passing in the width and the fill height. So that's how much we're actually going to fill. Top left is not going to be 0 anymore, but it's going to be 0 for the X. So we're going to still be there. But we're just going to drop down offset Y for the Y value. And we'll change this to be fill color, just like that. And let's see what this looks like. And anybody ew? So what's happening here is we drew our border first, then we drew our fill. And what's happening here is that the fill being on top of the border just doesn't look right. And we could do this and try to calculate how much space that border was taking up and then pull our fill in. But it's much easier to go ahead and use the painter's algorithm here to our advantage. Now, a painter's algorithm is just simply the last thing that you paint is the topmost. So it's just like somebody painting on a canvas. They'll paint some underlying things, they'll paint on top of it, the top stuff will take over, which is exactly what we're seeing here. We're seeing that this fill is taking over, being painting on top of everything else. So if we just reverse these, if we draw our fill first, then draw our border, things should look a lot nicer. So let's reverse these guys. I'm going to just take him and move him down below the fill. And if I run it, now that looks much, much better. So now that I've actually shown you what the issue was here, we're going to back it off to a more reasonable size. So we'll come back to here. And I think I said 3 before. Let's run that. And that should look much, much nicer. There we go. So now we have a gauge that's 0.6 filled. Now, there's a little bit of an issue here. I told you about size and offset, but what about stroke? Let's take a look at stroke. Stroke is a normal class. So what's going on here is every single time we are recomposing that screen, we are creating a brand new stroke object. And if that happens over and over and over again, eventually it's going to have to start garbage collecting, which is going to slow down the processing on the system, and we'll very, very likely see jank. So let's take a look at that stroke we're creating. That stroke looks pretty stable. I mean, it's not going to change. The only thing that would cause it to change would be the value of outline width px. So what we're going to do is use our friend remember. I'm going to come up to the top of this, and I'm going to say val outline stroke equals remember, and I'm going to paste that stroke inside there, just like that. But I want to make sure that this stroke gets recreated anytime the outline width changes. So I'm going to pass in the outline width as a key to remember. And what is he saying there? So we need to say key 1 equals. No, we shouldn't have to say that. What is with remember here? Composable can only happen inside. Okay. Canvas is not a composable function. So I need to make sure it's in the scope of a composable function. So if I move it out here, I'm inside of my overall composable function. And then he's actually accessible at that point. The other thing I could have done is, actually there was nothing I could have done inside Canvas. I'd have to create another composable function that took a draw scope and then use these guys, and that would not be a good way to deal with this. So we have to make sure that he's being used inside of a composable function, which is our gauge. Width doesn't change if you're in a composable function or not. He's just a common Kotlin thing that says, go ahead and pull this guy in as this for the scope of the body. So now I have this outline stroke. I can come down here and say outline stroke. Boom, just like that. And that's much, much better. So we'll just double check it by running it, see what it looks like. There we go. So next thing I want to try is a little quick animation on this, just to have it gradually fill up as it's animating. So what I'm going to do is come out to main activity, and we're going to start a coroutine, and that coroutine is going to be changing the value, and then we can use that to change the value inside the gauge. What I want to do is set up a little bucket to hold on to my value. So I'm going to go up to my set content, which is a composable function, and I'm going to say var value by, well, he's not a composable function. His lambda is run in a composable. He's kind of the root of all the composables. So I'm going to say value by remember mutable float state of, and you could just use a mutable state of, but it's a little bit more efficient to use a mutable float state. The difference if you use mutable state versus mutable float state, mutable state has to box and unbox the values. And what that means is that if there's a primitive value like a float, it's going to have to convert that into an object for mutable state to hold on to it. And then every time you read it, it has to convert it back into that primitive value. So by using mutable float state, he knows his value is a primitive float. Therefore, he's not going to have to do that boxing and unboxing. So it's much more efficient. I'm going to start that at 0. Well, let's start it at 0f, just like that. And then because the get value is not part of remember, it's an extension function, I need to import it here. So I'm just going to hit Alt-Enter and import him. There we go. And in order to change that, I'm going to start a launched effect. And this launched effect, I'm going to pass in true. You could pass in true or false, doesn't matter, just to say I never want to restart this effect. Inside of this, he's going to create a coroutine to run the body, and I'm just going to do an infinite loop here. I'm going to say while true, and I don't recommend infinite loops, but for an example like this, it's perfectly fine. So I'm going to say delay, and we'll pass in, let's say 250, see how that looks. And I'm going to say, so say value plus equals 0.1f, and if value is greater than, let's say 1.1f, we'll say value equals 0.0f. So we'll just start over again. And then now I'm going to go down here, and instead of had that 0.6, I'm just going to pass in value. So that should animate our gauge for us. Let's just take a look at what it looks like. And there we go. So we're jumping up 0.1 at a time. We could make it a little bit smoother. If instead of doing 0.1, maybe we say 0.05, and then let's reduce the time on this. Let's make it 100. That's a little smoother. Okay, notice he's going up and off the screen. That's just wonderful. So I really should have clipped that. Let me see if I can clip that real quick. So inside here, so I can say clip rect, passing in, let's see, so left top, left equals 0f, right equals 0f, top equals 0f, and size equal, bottom equals size dot height. Is that, so top, left, bottom. Oh, so bottom defaults to size dot height. I wonder if those are actually the defaults. Those might actually be the defaults of cliprect. Oh, right is size dot width. I might not have gotten that one right. Oh, I totally didn't get that right. Let's just try saying cliprect take in those defaults and see what happens. Hopefully, that's much better. So the clipped rec is making sure that nothing gets drawn outside that border. Think of it as though they put down a metal frame on the piece of paper you're drawing on. So no matter what you do, even if you draw onto the frame itself, it won't appear on the piece of paper underneath you that you're drawing to. Okay, so that's one little example. Let's do another example that is a clock. Let me see if I can find my clock one. There he is. And so what we're going to do with this guy is for drawing little tick marks on the clock and for drawing hands on the clock, instead of trying to figure out where exactly we should draw the hands, so start and end point, because they could be at any number of angles, what we're going to do is rotate the paper that we're drawing on so that we can always just draw straight up and down. And that'll make our life a lot easier. The rotation just applies a matrix onto all the operations underneath this, very much like the clip does. It applies a matrix to everything underneath here so that it will limit the values. Well, clip rect is more of a clamp operation. So let's say new project, empty activity. Yeah, so many fewer. I'm so happy. We're going to make this be a clock. And that's in summer. That's good. Bring him down there. And let's get rid of the gauge. Close him down. And what is he unhappy about now? Really? Oh, the version updates again. So I'll make that be 18. And I'll make that be 10. And sync it. Okay, so that should be better now. We should just get our hello world running here. There we go. Good. Okay, so far so good. So we're going to create our source main Java new clock. And we'll say it's a composable fun clock. And let's see what parameters we're going to need. We're probably going to need a whole bunch of parameters on this guy. So let's have hour, which is going to be an int. And note that this the types for the primitives like int look like they're objects, but they're not, even though it's an uppercase I. They just wanted to try to make it feel like everything is treated exactly the same, whether it's a primitive or an actual object. So hour minute. Let's get our modifier. And then we'll have outline, color. We have a lot of colors we have to have here. Let's say color.black. And outline width. And DP is going to be 8.dp by default. And then we have fill color, which will default to gray. And we'll have our hand color, and we'll just make him a dark gray. It's going to be a really boring clock. Then we'll have minute, which we'll make light gray. And then we'll have our tick color, which will also use black as a default. And then our tick length, which will be in DP. defaulting to 16.dp, something like that. So there's a bunch of good parameters for this guy. We're going to have to convert things from DPs to our pixels. So I'm going to say with local density.current, and then we can say val. Well, actually, the PX ones, we don't need to remember. We could actually do those in line because the PX function, let's say that I did outline width is outline width 2px. Let's take a look at what 2px does. And we'll see that he's just value times density. So it's a very quick operation, just a multiplication. Because of that, we definitely don't want to remember him. With remember has a good bit of overhead because it actually creates a node in the tree that you're going to be using for defining your user interface, puts a value in it, and then later on compares the value inside that node. So there's a good bit of overhead on that one. So if it's a simple operation like a multiplication, we're not going to want to remember it. We can go ahead and calculate it and use a variable here, or if we only use it in one spot, just call the 2px where it's used. We're going to have a stroke as well for the outline. So again, because stroke is an object that we're creating, putting him inside of a remember is a good idea. So I'm going to say val outline stroke equals remember, and then we'll pass in here outline width px, and inside of here I can say stroke width. Oops, let's import him. Width equals outline, whoa, come on. Outline width px, there he is. So that'll give us our stroke. It'll only change if the outline width changes. And then we can define our canvas, passing in modifier equals modifier. And we're going to have the same kind of pattern with doing a fill first, then the outline. So I'm going to say draw circle, and he's going to have a color equals fill color. So we'll do the fill first. Radius equals radius. Well, we need to define the radius. Val radius equals, well, actually, let's first of all define a diameter. And what I want to do is find which side, either width or height, is shorter. And based on that, I'm going to take 80% of it and use that as my diameter of my circle. So that way it'll fit nicely. So let's say val diameter equals min of size dot width. Oops. Let's see what happens here. Import min. He's going to be floats. Oh, I need to do that inside my canvas because size is available as part of the draw scope. So size.width and size.height. And then I'll just say times 0.8. So that'll give us a decent diameter. I need a radius for the circle. So I'm going to say radius equals diameter over 2. And now I can just say radius equals radius there. Finally, I'm going to say style equals fill. And if we take a look at fill, we'll see that he's an object who implements draw style, or actually extends draw style, whereas stroke is a class that extends draw style. So stroke is expensive to create a new one. Fill, there's only one instance ever, so there's never any problem with calling him directly. And I did a, we'll change him into a float. Is that going to do it? Oh, no, up here, let's put the times 0.8f. There we go, that's better. So what I had done is by saying times 0.8 he was actually making him be a double, I believe. Yeah, he made him be a double and actually wanted to be a float. So now he should be a float. There we go. So this is going to fill the clock. And then we can do the same kind of thing for outline the clock. Color is going to be outline color. Radius, we're going to have an outline stroke here. And that should outline the clock. So let's see if we have a, oh, he must default to the center. Let's take a look at him. I bet his center defaults to center. Yeah, center defaults to center. So this dot center is provided by DrawScope. It gives you a point in the center of the screen. So I was wondering for a minute, why didn't I specify my center? But we get that by default. You could, if you wanted to put it someplace else, say center equals, and then pass in an offset for it. Okay, let's take a look and see what we need to call him. And we'll go in here and say clock, passing in modifier equals modifier dot padding, inner padding, and what else do I need to pass him? Hour and minute and so on. So hour equals, let's say 10, minute equals 10, and is that all the defaults? There we go. Okay, let's run him and see how that looks. And we got a whole lot of nothing. So we defined our inner padding. Let's also say fill max size. That should take care of it. There we go. So now we have our circle. Inside of there, we drew our fill, then we drew our outline. So now we got to do some other fun stuff like drawing little tick marks at each of the 12 o'clock spots. So what we can do is every 30 degrees, because 360 degrees divided by 12 is 30 degrees, rotate to whatever hour tick we're actually marking. So back in my clock, we're going to say draw tick marks. And to do this, I want to have I'm going to rotate the paper 30 degrees for each tick. And I'm just going to draw straight down from the top of the circle down a certain amount of space. So in order to figure out the top of the circle, I have to back off the radius amount from the center of the screen. So I can say val start equals center. So I'm going to go for the center of the screen because going from the top, I have no idea how much space there is. Because the circle was starting at the center. And we'll say offset of 0f. So we're not moving anything for x. We're just right in the center there. But we're going to be subtracting the radius. And so there's my start. Then I can say val end equals start at that start point, and then I'm going to go down my hour tick length. So I'm going to say start plus offset. Again, we're not changing x. We're just going to go down to the center there. And we're going to take our tick length 2px. That'll be our endpoint. So this is going to be a little line that we're going to draw using those. So we're going to repeat, and this is a function provided by Kotlin, 12 times. And each value in here is going to be our hour tick space. And that's going to have the values of 0 to 11. So when repeat runs here, the values he passed in is going to be 0 through 11. We're going to repeat 12 times, and what we're going to do is rotate the paper and then just draw straight down over and over and over again. So I'm going to say rotate hour tick times 30 for 30 degrees. Oh, wow, that just did not work out well at all. And then inside of this, and again, all the rotation does is define a matrix that is going to be multiplied against any graphic operations you do to transform points on the screen. If you take a class on graphics, they go into a lot of details on how all the matrices work. It's pretty cool and pretty efficient. So draw a line, but it's a lot of math. So we're going to do a draw line with a color equals our tick color, and start equals start, end equals end. Ooh. And stroke width is outline width px. So that's how we're going to draw all of our tick marks. Let's see how that looks. There we go. Comes out really nice. And that's so much easier than doing all the sine and cosine calculations you'd need to figure out exactly where the start and end points for these should be. All we do is tell the system to apply this rotational matrix for each drawing that we're doing. Nifty stuff. Okay, so now let's draw our hands. So we're going to start with our minute hand. It's one thing I hate about English, how you can pronounce the same word differently and it means different things. It's like if it's written down, it's, you know, it can be very hard to tell the definition of it. Okay, so we're going to draw a line here, and we're going to rotate it. First of all, we're going to rotate again, and then draw a line straight down. So I'm going to say val minute ratio equals minute divided by 60f. So it's going to tell us what proportion of the circle we're going to be moving to draw the minute hand. And then I can just say rotate to that minute ratio times the number of degrees in the circle. And inside there, I'm just going to draw another line. So I'm going to say draw a line, color equals minute hand color, start equals center minus offset 0f. Again, we're not moving the x, and I'm going to say the minute hand takes up, let's say, 80% of our radius. So we'll say radius times 0.9f, just like that. And then end is going to be the center. And it doesn't matter which one you use, start or end there. And then stroke width is going to be outline width px again. Now you could pass in some other parameters for different sizings of the hands, or maybe even a drawable to represent the hand instead of just a line like we're doing here. Okay, let's see how that looks. It should be at 10 after. There he is. That looked like came out perfect. Let me actually make him a little shorter because he's touching right there. Oh, I made it 0.9. I wanted to be 0.8. Let's try that again. That'll probably look a little better. There we go. That's pretty good. Okay, so now we'll do the same kind of thing for the hour hand. And the hour hand's ratio is just a hair more complex because we want him to move as the minute hand is moving. So I'm going to say hour ratio is going to be hour plus the minute ratio. So we're just going to take that, that portion of the circle and then divide it by 12. And then this can be hour ratio times that. We're going to draw using the hour hand color. And let's see, how big did I want to make this guy? We'll switch him down to, let's say, 0.5. And I think that is that. Let's try him, see how he looks. There we go. So now we have a clock with hour and minute hands. But the center of it looks a little weird where they're joined. So what I'm going to do is I'm just going to draw a little pin on top of that. So just a small circle, just to make it look a little cleaner. So we'll come in here and we'll say add a pin to the center. And we can just, again, draw another circle. And the color, let's use the hour hand color because he's on top. And then the radius is going to be just the outline width, px, and the style is fill. That should make it look a little bit cleaner. There he is. So we have that nice little pin in the center like a clock normally has. So let's go ahead and animate this thing. We're going to go back to our main activity and we're going to set up some animation on it, just again moving through the time. We'll just keep increasing the minute and then let everything else take place from there. Let's go back to our main activity. Inside our set content, I'm just going to say var hour by remember mutable int state of, and we'll start him at 0. And then we'll do the same thing for minute. Import those gets and sets. There we go. And then we'll have a launched effect again. And I'm going to once again use an infinite loop here just for the demo. And we'll say minute plus plus if minute is greater than 59, then minute equals 0, hour plus plus, and then if hour is greater than 12, hour equals 1, and then we'll delay it just a little bit here. Let's try 25, see how that looks. And now instead of having those, I can just pass in hour and minute. And we'll run this, and hopefully we will see a clock running. There we go. That looks like it's working pretty well. So we have a nice little custom component that we've drawn here just to do a clock on the screen. And this is a really oversimplified one. We could get a lot fancier, use an SVG for a background or an SVG for the hour hands and the minute hands. I was starting to play around with that, but some of the art I was finding online, people who've defined art for clocks and clock faces, they tend to put everything in one big SVG. And so the problem was pulling out the individual pieces and making sure that they were all 0 aligned. So I was playing with that for a little bit, and it was just getting too fiddly. I may do that at some point, but it just didn't seem like it was worth it. Would have looked a little cooler. But this still makes a nice example.